Hi guys, in today's video, I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing the mean value theorem. The mean value theorem gets tested very frequently on the AP Calculus BC test. So actually is tested on AB as well, AP Calculus AB. So let me start. So if a function, so the mean value states that, I'm just going to write down the entire statement. You should also copy it down as it's very important. So if a function is continuous on a comma b. So this is a closed interval and differentiable on an interval a comma b. This is an open interval and this is a closed interval. Then there exists a number c in a comma b. So it's in between a comma b such that the slope of the tangent line at that point is the same as the slope of the secant line So this is the mean value theorem. And the points of secant C are A, comma f of A and B, comma f of B. So now let me give you an example. I know this might seem confusing at first, but once I draw this graph, you'll understand. So let's say we have this. So we have something like this. And then we have our function f of x. So this is f of x. This is A and this is B. Now we can, wait, let me try to draw a line. Yeah, we can draw a secant line from here to here. So this is a secant line as it touches 2 points. Sorry, second. Yeah. And now let me draw a tangent line which touches only 1 point. So it's like this. Yes, perfect. So now this is f of x. So this curve, f of x. This is our secant line. And this is our tangent. And this point right here where the tangent touches the graph f of x is C. So that is what C is. So now if you read it, you'll understand it better. So you can see that this function is continuous on a comma b, and it is differentiable. So I remember we talked about how we can know if a function is continuous or differentiable in an earlier video. We saw that a function is continuous when, like, to give a simple example, it's when you can draw the function without taking out your pencil from the page. So you can continuously draw it without having any breaks. And the function is differentiable if there are no, for example, if there are no cusps, no sharp turns, no holes, etc. So we know this graph has none of these. So it's continuous and differentiable. So that is proved. Then there exists a number C in between A and B. So we can see that C is in between A and B, such that the slope of the tangent line at that point, So we know that the slope of the tangent line is the same as the slope of the secant line. So what do we know when the slopes are the same? When the slopes are the same, the two lines will be parallel. We can clearly see that these two lines are parallel, right? So yes, the mean value theorem is satisfied. So now hope you understood it better. If you have any questions, you can let me know in the comment section and I'll try to answer them for you. So now one formula you must know for mean value theorem is f dash of c is equal to f of b, sorry, f of b minus f of a divided by b minus a. So this is what the mean value theorem states. So f dash of c equals f of b minus f of a divided by b minus a. So now let me give you a small implementation in mean values theorem. It's called Rolle's theorem. It's called Rolle's theorem. That is in the mean value theorem, but if f of a is equal to f of b, then there is a value c where the slope is 0. So the slope of the tangent and secant. So when the slope is 0, we know that it's a horizontal. So this is what Rolle's theorem states. So now let me give you a question using mean value theorem. So they have given that, so firstly f of x is a continuous function, and they've given that f of x equals x squared minus 6x plus 12. So x squared minus 6x plus 12. And then we have the 2 points a and b, which is 2, 6. And they're asking what can you judge using the MVT? Try to find the value of c. So try to find the value of c. So 1 second. Okay, so first what we can do is, we remember that formula we used, f dash of c equals f of b minus f of a divided by b minus a. So we know that 6 is b and 2 is a. So f of 6 minus f of 2 divided by 6 minus 2. So if we substitute 6 into this function, you get 36 minus 36 plus 12, which is 12 minus, if you substitute 2, you get 4 minus 12, which is minus 8, plus 12, which is 4, divided by 4. 8 divided by 4 is 2. So now we know that f prime of c is equal to 2. So what can we do with f prime of c equals to 2 to find the value of c? How can we find c? You can differentiate f of x, right? So you get f prime of x or f dash of x equals 2x minus 6. So now you can find f dash of c, right? You can make it as f prime of c equals 2c minus 6. What is f dash of c equal to? That is equal to 2. So let me just clarify one thing. If you say f prime of x or f dash of x, they mean the same thing. They just mean the differentiation of f of x. So 2c minus 6 is equal to 2. 2c equals 8. So c equals 4. So now we found our value of c. So now we can say that since our function is continuous and differentiable on the interval, then at x equals 4 in the interval, the slope of the tangent line at that point is the same as the slope of the secant line. So that's what we have to write as our final statement. And if we write that, we can get full credit for this question in our AP Calculus BC exam. Okay, that's it for today's video, guys. In today's video, I discussed the mean value theorem and the Rolle's theorem. If you have any questions, please let me know in the comment section below. Thank you.